In this video, I'd like to answer problems 13 and 14 from homework assignment number 6. The first one looks like they give us data where we have different weights for cars and their gas mileage. They give us an R value and looks like a linear regression equation. And it says, what proportion of the variability in miles per gallon is explained by the relation between weight of the car and miles per gallon? So for the proportion of variability, we can square the R, right? So if I were to take this negative 0.982 and square it, let's do that. Give me a moment here. You see I get, oops, I forgot to square it. Sorry about that. Let me square that answer. There we go, 0.964. So it says we need to, I think, round to one decimal place. So as a percent, we have to move the decimal 2 places to the right. So it would be 96.4. So I'll put in 96.4 and check answer. And again, to repeat, how did I get this answer? I squared the R and then moved the decimal place 2 places to the right. I'll also show you how to use StatCrunch to come up with this answer as well. So it says construct a residual plot to verify the requirements of the least squared models. Choose the correct graph. So basically, for the residual plot, we don't want these things to fall on a perfectly straight line. So we're hoping our graph does not look like C or D. Here's my data, and we'll open this up in StatCrunch. And we can press Stat, Regression, Simple Linear, and our X is our X variable, Y is our Y variable, right? So weight is X, gallons or miles per gallon is Y. Let's see here. I'm going to do residuals versus the X values, and I'll save the residuals. I don't think we need to actually do that, but I'm going to save them. And I press compute. And again, notice I said versus the X values. That's what the graphs we were provided show us. So here are my residuals. And if you press the arrow on the bottom of this data, you will see a plot of my residuals. And I can press the arrow to go back. And I just wanted to show you the R squared. See how it came out to be 0.963? And maybe, depending on how you round, it might be 0.964. Or I'm sorry, 96.3 or 96.4. So that value, us squaring this, did work out. So a plot of our residuals. Right, so here's my 0. It looks like there's maybe 1, 2, 3 points above the 0 in the beginning. So let's see what they give us here. Here's my 0, 1, 2, 3 points above that 0, right? This one's close, but you don't see this letter A looks more closely to what we came up with in StatCrunch. Right here is my 0. Just imagine there's a line going through here, and right away you see we have the 3 points that rise, and that seems to match choice A. Check answer. Nice work. And it says, okay, so interpret the coefficient of determination. So we're going to use this 96.4%. 96.4% of the variance in weight, gas mileage, sorry about that, is explained by the linear model. The least square regression model appears to be appropriate based on the residual plot. So this would be inappropriate if our plot looked like this or like this, right? If we had a straight line. You want the residuals to be kind of scattered out randomly. Okay, so let's check our answer. And we get a fantastic. Let's do number 14. All right, so number 14, it says the data to the right represent the number of chocolate chips per cookie in a random sample of the name brand and a store brand. Complete parts A through C. So it looks like we need to do 2 box plots. So I'll open up my data, open in StatCrunch. And if I want to do my box plot, I can press graph, box plot. First we'll do name brand. And I'll put the median line through my box plot, and I believe you want to draw the lines horizontal. Here we go, draw boxes horizontally. I press compute. There's my name brand, right? It says name brand down here. And then let's do it again for store brand. Box plot, store brand this time. We'll draw boxes horizontally, and I want to see the median. Compute. And if we do these, let's see if I can get them, just so we can get a good look at them lined up. You kind of notice how my name brand, the median goes through, looks like 26, whereas the store brand goes through 25. And then when I look at these fences, my name brand goes from 22 to like over 34. So let's see what our choice is here. So it looks like, I'm thinking my choice will be either A or C. I want to just really take a better look at the details here. So looking closely, I think the correct answer is going to be A, because when I look at my name brand, it looks like the lowest value here is about 22, and it goes out to maybe 34, whereas over here it looks like we go out to kind of like 40. So when I looked at my original, right, notice how my data goes out just past 34, and starts with just after 22. So let's take a look and see if we're correct. Yep, fantastic. So it says, does there appear to be the difference in the number of chips per cookie? The answer is yes, because the median of the name brand is greater than the median of the store brand. So I'll say the name brand has more chips per cookie. And then the last question is, does one brand have a more consistent number of chips per cookie? Well, that would be the brand that has a smaller spread. So the store brand is really spread out, right? It goes from down here to, let's see, 12, 14 to, I don't know, 34, whereas the name brand only goes from, say, 22 to 36, right? The spread for the name brand is smaller than the spread for the store brand. So I'll say yes, the name brand has a more consistent number of chips per cookie. That's it. So that's problems 13 and 14. I hope that helps. Thanks for watching.